zijn. Ik denk dat onze zaal niet echt veel meer volk aan kan. Het is altijd tof om te zien als het in Gent is dat het volpak is. Dus dat is altijd leuk. We hebben vandaag twee heel interessante sprekers gevonden. We waren een beetje last minute. In feite zijn we lui geworden bij PHPBenelux. Hoe komt dit? Omdat wij in januari een klein conferentietje georganiseerd hebben. Daar kroop verdacht veel tijd, daar kroop verdacht veel tijd in. En we hebben gewoon tijd nodig gehad om wat aan decompressie te doen. Maar we zijn terug en we gaan jullie gedurende het jaar goed entertained houden met allerhande events. En dit is er eentje van. We hebben 2 talks vanavond. Eentje van Jurriaan Persyn en eentje van Xavier de Keister. En ik zou graag Jurriaan uitnodigen om hier het kot plat te spelen.
Eerst en vooral, waarover wil ik het hebben? En dat is over search toevoegen aan uw site. Ik veronderstel dat de meesten onder jullie werken met PHP en SQL, dergelijke sites bouwen. Oké, dan wil ik daar een search engine aan. Misschien bekijken.
Spreekt iedereen Nederlands hier? No? Okay, English. So everything I said, welcome. We've been lazy, but this is our event. This is Jurriaan, Rookie Cat. Let's do it.
My slides are in English, but I think it will be better that I talk in Dutch, just to be at ease. If there's anything, just stop me during the presentation, and I can give some.
Can we stop you and ask you to speak in English?
Okay, I'll do my best. Okay, thanks. Whatever. So this is about adding a search engine to your site. I'm assuming most of you guys work with either PHP or MySQL, or at least the majority of you. So what if you want to add a search engine to that type of application? So I want to talk about how you can you do search in MySQL, then about what search engines specifically designed for search, what their features are, and then the main thing is about Elasticsearch, how we at Engager use Elasticsearch to do that kind of stuff. There will be a lot of code in there, so that will be the examples of using Elasticsearch, so I hope you can go home and start with it immediately. About myself, so I'm Jurriaan, I'm working for Engager, that's a social media monitoring application. We're started from Ghent, we're 2 years old, and what we do is monitoring social web, monitoring Facebook, Twitter for clients. That's mainly big companies, a few Belgian companies like Bellacom or Telenet, a few more European clients of us are the European Commission, Microsoft Europe, etc. Before I worked at Engager, I was a lead developer at Massive Media and worked on the Netlog and Gacha products. So that's where I got my expertise in performance and scaling from. But not in PowerPoint. So what is search? Search can be something very simple, just a single query, in this case searching for funny GIFs on Tumblr, because that's what it's for. But search can be a bit more complex, searching on certain types of fields. So a combination of I need that field, that needs to match that, there will be nesting in there will be ands, ors, nuts in there. And then the next step could be like something like the graph search, where you have different types of data, connections between them, a whole graph of information, and searching in that. So it can be something very simple, but it can be also become something very complex. Now, starting at the simple part is, if you think about how would I add search to my website, probably the first thing that comes in mind is something like this. Okay, why not? It works. If you have a lot of data, you might have to rethink it and maybe put an index on there, something like a card index box to keep the library analogy. But MySQL actually has help for that, a specific index for text search. That's a full text index, something you add to your table, and it can be added on my ISAM tables only, and only for char, varchar, or text columns. What are the other features it offers is like you can configure some stop words that it should be filtered out, and there's 3 types. the natural language type of index. That one is the simple implementation. Natural language with query expansion is actually a double search. Say you're searching for databases, it will do a search for that, and then it will return like the first 100 documents, try to find what the most common words in there are. Probably that will be MySQL, Oracle, and then do a second search with those expanded keywords. That's the second type of index you can use in MySQL. And then the third type is with Boolean operators, and that adds some functionality to the natural language type of index, where you can use ands, ors, flops, wildcards, etc. Actually, the next slide is exactly that. These are the operators you can use in a Boolean mode. So ands, ors, brackets for nesting, wildcards, literal matches, and the or is implied, so a space is an or. Now, with this full text index, a typical way of adding search to your site would be creating a separate search table, and every text you have in your application, the blog posts, comments, whatever that you have, save a duplicate of that text in that search table and store, in this case, type and ID fields to couple back to your original information. So if you search in your site, you search this search table and then couple back to the original data to show that. I guess this is the way most people would implement search in a standard application. I guess this is the way that PHPBenelux implemented it back in the days, I guess. So one of the first sites I did with PHPBenelux, that search table always crashed, by the way. I don't know that. Anyways, we have this search index. This would be a query that searches for shizzle. This would be a query that searches for shizzle but doesn't search for manizzle. But the next step, like filtering on certain fields, give me jobs that match a certain word, but also the role of the job should be developer. If you want to do stuff like this, then you have to use combinations of indexes in MySQL to keep it performant. And then even, especially for jobs, there's even more stuff you want to add there. So in the end, you're adding a lot of indexes, and depending on which fields your users are searching for, you'll have to use different sets of indices and in different orders. So it becomes very complex, and adding lots of indices to your table makes it slower on write operations. So you have drop. And that's because you're not really using a search engine, you're using a relational database management system with a couple of search features. Now, what is a search engine? First important thing is it needs indexing of your data in an efficient way on all fields and all combinations of fields, because your users can be searching on a whole set of combinations. Next, the data you put in there, you want it to be analyzed so that if you search on a certain word, it also finds matches with words that are the plural of that single word you're searching for. You also want it to understand, if you're adding a date to it, that you can do range queries on that date. So it needs to understand what you put in there. And then the third feature I'm talking about here is you want the results that come back from that search engine to be sorted in a relevant order. You want the first page of Google to be the most important matches. What is tokenizing? Tokenizing is a feature that's in most search engines, and that's responsible for splitting your text into words. And that's not just an explode on a space character, because, like, for example, in Chinese there are no spaces. Also, if you have like it's with a dash, mistaken. So it's harder than just a split and explode on a space. You also want to understand patterns in your text. If there's an email in there, if there's a hashtag in there, if there's a currency in there, you want your search engine to know about what data it is handling. Next up, stemming. Stemming is finding the stem of a word. Okay, pretty simple. If your words like fishing, fish, fish, fisher have the same stem, and that's fish, the stem of better is good. So you want that your search engine understands what you're searching for and finds matches based on, for example, the stem of it. How is stemming implemented? Like, it can be via lookup tables or stripping the suffix, which is probably in English quite simple, but I imagine in some other languages completely impossible. And actually, this stemming thing it's just a whole language processing is a science at itself. So it's a difficult, very difficult thing that's not in MySQL and that you want and can use in search engines. Also, you want, if you're adding data to your index, you want the stop words out of there. Maybe you don't need all HTML if you're submitting or indexing web content. So what goes in there has to be filtered. Then about understanding the data you're adding. One of the good examples there is if you had a geolocation, a point, you want to be able to search on the bounding box, this distance, or a geopolygon, like searching within a country. And MySQL actually has a separate index type for that, but also you want to have it integrated that you can search within a country for a certain word and with a match on a certain field. So that's where you need search engines. Now, from the documents you found, like how do you sort them? In what order do you get them back? There's a couple of strategies, like, okay, how many matches were there in the document, or how many matches as a percentage of how long the document is. That can be an indication of how important or how good the match was. But you also want to have custom scoring, like depending on the type of data you're putting in there. And that custom scoring can be something you add at the time you add data to your index, but it can also be something that you want to define at the moment you're querying your index. Luckily, there's software for this, and it's called, surprise, surprise, Lucene. Lucene is an information retrieval software library. It's actually from '99, from last century, so it's pretty old, but it's used by lots of companies in lots of products, and it's still an active product. And this Lucene is a Java library. So it's a set of APIs that is responsible for all features I just discussed last minutes. Now, of course, a Java library isn't something you immediately use in production. If you have lots of data, you need it to be sharded, you need it to be highly available, and those are not responsibilities of Lucene, or that's not implemented in Lucene itself. What you need there is ElasticSearch. And ElasticSearch is a pretty new product. The first official public release was in February 2010, so it's just celebrated its second birthday. And it's built on top of Lucene. Why on top of it? Because you need a few extra features. You need it to have an API, you need it to have clustering, you need it to have understanding of sharding data, etc. And that's built on top of Lucene. Elasticsearch itself is in Java, so you can use it on any platform you like. And it was a rewrite of the Compass project, but like the guy who built it, Schema, decided in February that he just had to restart the project call it Elasticsearch, and have the clustering functionalities, the performance functionalities, the scalability features built in right from the very start, because that's what sets it apart, and that's what was needed at that time. So, on top of Lucene, it adds like these three important things. First of all, an API, and that's a JSON API over HTTP. So you talk to Elasticsearch like you would talk to the Facebook API, and you put JSON in, and you get JSON out. So if you want to use it from PHP, you just do curl requests like you would do to any other API. Second important feature is like the clustering I talked about, and the fact that you can put up a cluster with 10 servers and have lots of data in there, and it automatically balances everything, makes sure there's failover mechanisms in there. So that's what Elastic adds. And it also has long-term persistency. So what that means is that if you add data to your index, it can write that through to a data backend, so you're sure to never lose that data in Elastic. It's not just an index, it can also store the data. If you want to install it, the simple way is this. So 5 comments, download it, and you run it from your downloads folder. A bit more clean is to wrap it up in a service and install it in the right place. And that's it. At this moment, Elasticsearch is installed on your system. That's it. You start it like this, and what you have then is a HTTP server running, where you can just surf to. Here I'm surfing to my local host on port 9200, the default port. Okay, that's Elastic. And that's the interface, and that's all you need actually. If you want to secure this, secure it with a firewall, or put it on a separate port. If you want to cache it, put varnish in front. It's as simple as that. In this example, I'm adding some data. Actually, so to my local host, in a test index, I'm adding a stupid hype, namely planking, stupidity level 5. I just post it to there. What I get back is the ID of the document, the index it's been adding to, the type, and it's the first time, or the first version I submit. Another index, even stupider, gallon smashing. Oh, but I just put stupidity level 5, actually it's 10. So new version, new ID, it's added there. If I want to see this record, I just surf to the URL. Localhost, test index, the type, and the ID. And this is my document. You see, it's version 2. This is the document I submitted. That's it. If I want to make sure I remember the lifetime of this stupid type was only 30 days, I just edit there, have a new version of it, and the new field is available. So what you see is that Elasticsearch is schemaless. I didn't have to create an index. I didn't have to define what the index looks like. I just put it there, and it understands my data immediately. No alter table operations. Those might require some time if you do it in MySQL. But actually, you can use a schema. You can define a mapping. And if you do that, that is to require certain fields to be of a certain type, or for performance reasons. By default, Elasticsearch will guess what the type of data is you add to it, and if it's a string, it will probably do analyzing on there. But if you know, okay, I'm just adding it there, and it doesn't need to be analyzed, there doesn't need to be any stemming or tokenizing on that, you can define that in a schema. It's not needed, but you can use it to give Elasticsearch some hints. What we have now is just an OSQL store, right? We just put data in there, get it out. That's it. So Elasticsearch is exactly that, but you can search it. Here I'm searching my stupid hypes index for the word. It's very small, but this says Q is smashing, and I get the document back. You see it has got a score, it shows how many shards it had to look in, and very small index, we haven't put a lot of data in there, of course. this is the same example as this, where I do a get query for smashing within PHP. I guess most people have worked, or all of you have worked with curl in PHP. This is the way you will get data in your application from your search index. I've used a few terms by now. Maybe let's go over them. So a database in MySQL is an index in Elasticsearch. A table is a type. A row is a document. A column is a field. Schema is mapping, but you don't need it. Index, there is no concept of index in Elasticsearch because everything is indexed in every possible combination. You query MySQL via SQL. You query Elasticsearch via query DSL, and that's a language specific for that's for Jurriaan and Elasticsearch, and the way how you define your queries. Do you want to select data from your Elasticsearch cluster? It's GET requests. Do you want to update data? It's PUT requests. Now about the cluster and the high availability. What you have is you can create one server, or you can create a cluster with 2 servers, or for Engager we have a cluster running with now 12 servers, and they just act like a single service. You just access it in the same way as I'm accessing on my local host, and the nodes in that cluster are responsible for sending the requests through to the server that is actually having that data at that moment. In your cluster you can define nodes, servers that are storing data, but you can also define nodes that just compute queries, that are just there to add power to it without storing data itself. Elasticsearch is also responsible for sharding your index. So if you have a very big index, it will split it up in little parts. And you can define, if you want, how many shards there need to be, how big those can become. And you can also define how much replicas of those shards you want. Typically, or in our case, we have, per client, we have indices, or multiple ones. And then every those indices are sharded by month mostly, and those shards are always replicated twice. And what Elasticsearch does is those replicas of the same shard, it makes sure they are not on the same server. So if one server goes down, not a problem. All queries for that index go to the other server that has a replica. If the server comes back up, it just will sync itself and make sure the replica is updated again and your service stays available. If you are scared that if 2 servers go down, those replicas, then you might have a problem, then you just configure every shard to have 3 replicas. So depending on your needs, you can either scale in servers that do computing, or servers that do store data, servers that are responsible for more shards, more replicas, to make sure you don't lose any data or are always up. And this sharding is the responsibility of the master database, or the master node, sorry. And that master slave is something that also happens automatically. So every server in your cluster can become master at some point. The decision on which server or which node in your cluster is master is done just on the fly. If you start it up, it might be that server 1 is it. Next time it can be that server 3 is it. If server 3 goes down, then there will be a new round where they decide, okay, now it's server 4.
So which one do you address when you query? Is there a sort of one IP you have to address? Or?
You can address any one of them. If you have a cluster of 5, you can just talk to server 2, and server 2 will be responsible to get the data from whatever server the index is on.
So you just load balance those IPs of the several nodes, and
you just pick a random one actually. If we connect to our cluster, we just pick a random one from the server, and that's it. Or some of the requests originate on one of those Elastic servers, then we just query the local one, because that's what has the least network latency. So you can address any one of them. There is no need for you to load balance. It's ElasticSearch that load balances for you. This is our dashboard for our ElasticSearch cluster in Engagement. What you see here is 12 servers, named from 2 to 14 with no 7, so that's historically. In this case, the green stuff is okay. Server 8 knows who server 9 is. They know each other. Server 12 is in blue, and that in our case means that that's the master at this moment. Right here is a number that says primary and then 11K. That is the amount of shards we have in that cluster. The amount of primary shards, so the real amount of shards we have. And in total, there are 22K, so here you see there's a replica for each one. Held means that there is no, or in how we implemented it, is if it's green, then there is no rebalancing going on. If one server goes down, and half an hour it comes back up, you'll see that it is moving indices across the cluster to keep everything balanced again. Now, scaling issues, as I said before, there's no need for a load balancer. If you have more data, you make more shards, more nodes. If you want higher availability, you can create more replicas. Some performance tweaking maybe. You can add data to it in bulk. Then you avoid some network latency, say with multi-gets. You can also do multiple queries or multiple searches in one HTTP call. ElasticSearch has an API, the same JSON API as to put data in there, to get the availability state, to get the health, to get the amount of memory a node is using. And those APIs are what we used for this. And maybe if you want to have an alternative for the HTTP API, you can talk to the Java library itself. Or if you don't like to be responsible for the curl requests yourself, you can use some PHP wrappers. There's 3. I've listed 2. But actually what they do is just create a wrapper for curl and then create a wrapper for the objects you get back. So the simplicity of the API is more than enough, and I don't really see the use case for a wrapper for that. So okay, that's a lot of features. Now maybe it's time to give some examples on how we use it. And the examples I want to give are with the application we're building now. So maybe it's a good idea to explain what Engager is from a more technical point of view. Actually, it's a database or an Elasticsearch cluster of social messages, of tweets, Facebook posts, Facebook comments, Instagram photos, whatever social message we track for our clients is stored in Engager. Right now we have, since our start 2 years ago, we have just reached the milestone of 1 billion messages. So that's what we have on our service. That's what we have to query. That's what we are showing statistics about. So those messages, what we do with them is show graphs of the daily amount of usage. We add workflow tools to it so that a customer service team, like the customer service team of Movistar, can use this as a team and can start replying on your Twitter complaints and stuff like that. This is a slide I stole from our CEO that shows where we come from. So the number I wanted to definitely tell is like the 1 billion stuff. And it's pretty cool. We're now 16 people too, so that's pretty nice. This is an example of where we search one of our clients' indices for a certain name. So what you get back is, okay, we have 260 hits for this search on Caldini, one of my colleagues. And here you have how we represent internally what a social message is. So the index we have is one index of all these fields. What are typical fields for what we save is, okay, it's coming from either Twitter, Facebook, or any of the other sites. What is the message itself? What is the date? What are the author's details? Its avatar, its ID on Twitter, etc. Now this is a simple search, but the second example I showed earlier, the third slide or so, is actually a screenshot from our site. Where here we are searching the tweets or every message from Belgacom and Mobile Vikings, two of our telcos, for messages that have at least, users that have at least 1,000 followers, where the sentiment is negative, and where the language is Dutch or the country is Belgium. So that's the list of tweets we get back. So it's actually a pretty powerful interface, and the way why we can add this to our users and why it is still sub-second page loads is because of Elastic. The query that is built here.
Question.
This is.
How do you find sentiment negative?
So we have an artificial intelligence system where we can just put in text and it comes out positive or negative.
Okay.
Actually, that's Jurriaan right here that's working on that. So data science. For the previous query, this is what we sent to Elastic. Okay, that field has to be NL. The location has to be this. The sentiment it has to have a tag with sentiment negative. So this is the equivalent of using SQL but for ElasticSearch. Now, Movistar and Belgacom or Mobile Vikings have about, I think, 500 to 1,000 mentions a day, except on the day they do press release. But we also have some demo data or some bigger accounts like Microsoft. And this is some demo data for Coca-Cola. What you see, like the average amount is about 50K messages per day. This is a graph of 28 days, so it's 1.4 million of messages. What we do here is show a graph of that 1.4 million messages, and it's real time. If a new one comes in, we refresh this page, this one will go slightly up. This is the inbox of that topic. So the last 10 messages about Coca-Cola. Here we have our debug, internal debug bar, and there is one URL called. This says URL, and this is like the information about the curl request that happened, and this is always sub-second performance in those 1.4 million messages. This is the same page, but now we're searching for, this says thirsty, and actually it's even faster. So what happened here is we're searching 1.4 million messages, and we have again sub-second, or in this case, it is there. Here, 0.4 or 357 milliseconds to query that data. And that is because of Elastic. Nothing more, nothing less. Now, searching can be, okay, I have a query, give me the documents that match it, but searching can be a lot more, and that's where what facets are. So instead of returning the actual documents, you return a distribution on a certain field of those documents. If you go back to this query, we don't return the 1.4 million documents to our PHP script and then distribute it to calculate this, of course. It's a facet query to Elasticsearch. Give me the per day, so a distribution on day, and then per day how many messages there were. And that's what a facet is. You can compute totals, like, okay, for if I do a facet on the language field, okay, for Dutch, how many messages do I have? For English, how many messages do I have? But you can also compute averages, like what is the average amount of followers our users or the user users that we tracked have. You can also compute distributions, minimums, maximums, etc. So back to the terminology, like a facet in Elasticsearch is kind of a query like this. Right here, you see a page where we show sentiment distribution on the Pulp Fiction topic, demo data. Actually, if you want to see this at work, you can just go to our site and create a 2-week trial demo. Probably at the end of those 2 weeks, a sales guy will contact you and try to convince you to buy a subscription. Then just blame me. And that Pulp Fiction data is in there, telco data is in there. There's lots of data to play around. So what is this graph? This is a facet on sentiment. We ask our Elasticsearch index for the sentiment field you have, what is the distribution of the possible values? Okay, 40K neutral, 20K positive, 10K negative. This is the same, but here we're doing a facet search on 2 fields, namely the date and the values. So in one query, actually those 2 graphs can be computed in one query. We ask Elasticsearch what the distribution is of the possible values of the documents in there. Now we can also combine this. So what you could do is search in this index for every message in Dutch, and then have this same type of graphs. So this is about all the data, but you can refine your search query that the matching documents are less, and then have that same facet computed on there. Another example is where we have this graph of the Telenet Twitter account. Again, this is live data. If you surf to our application, this graph will show exactly what is computed on or what we have for that account. It's not that we one hourly compute this. This is always live, and this is always, or for this graph, it is one query to the Elasticsearch cluster, a facet on date, and then several query facets on types of messages. Here are the blue stuff is just mentions of Telenet. The purple stuff is replies on Telenet. This green are retweets of Telenet tweets. So this is a graph that shows like an overview of the performance of the Telenet Twitter account. Some even more advanced features are the nested documents. You can add documents to Elasticsearch that have parent or child documents, and that's a bit like combining 2 types of data, like a MySQL join, to put it simply. Then there's a very cool feature, or maybe like a little mind game, where you don't send documents or put documents in Elastic, but what you put in there, or that's a percolation, what you put in Elastic is queries, and then you just, instead of throwing queries to it, you throw documents to it. And instead of that it returns documents, it returns which queries that were matched. I'll try again. Say you have like a Twitter Firehouse connection, or data is just coming in, and you need to decide which tweet goes to which client. What you want then is an index with, okay, client A needs all documents matching X, and client B needs all documents matching Y. So in Elasticsearch, you put your queries, and then you just throw the tweets at it. And it returns, okay, this is for client A, this is for client B. So just the other way around as normally using an index. It's a pretty cool feature. Third one is index warming. And that's something that's interesting if you have certain queries to Elastic that require heavy load, that are difficult to compute. what you do there is tell Elastic, okay, these are queries I'm often executing or that I want to have pre-cached. And then if you add data to ElasticSearch, it will make sure that the next time you do that query, that heavy query or that query that you do often, is already in memory and ready for you to be served very, very quickly. So I imagine this would be something that 2 or bigger sites with lots of users could use to cache their queries that happen often. Now we've talked about Elasticsearch, but what are my other options? There's lots of databases that have a few of the search engine features. You could use NoSQL, and probably some of those also have some search features. Then if you look at the search engines themselves, there's Solr, there's Sphinx, Xapien, or you could even use Lucene itself if you want. And if you're looking at services, Amazon also has a search engine available that you can just load up at will. I'm picking out 2, like Solr and Sphinx, because that's what Elasticsearch is most like. Solr is also built on Lucene, a similar feature set, also exposes some of the Lucene functionality, so very as powerful or as easy to extend. It is an Apache project, and actually now it's becoming a part of Lucene itself, and it's perfect for like single service search. On the negative side, there is some clustering, but it's a pain in the ass. And I'm saying because we've used Solr, the first versions of Engager ran on Solr, and we just outgrow that application, mainly because Elasticsearch is just much better at it and easier to set up, because it's been built with that performance and availability in mind from the very start. Also, if you're looking at the Solr code base, you'll see there's lots of branches, so you might get lost in there. If you look at Sphinx, and that's something that Netlog and 2 are using, they used it when I was working there, and apparently they're still using it. And it's very good because it has a very cool integration with SQL. You can just say, okay, my Sphinx server, use SQL as a backend, and it will make sure everything you put in MySQL is indexed in Sphinx. So that's very cool, and it's also very, very fast for simple searches. If you're just doing text searches, Sphinx is a very good option. But again, no clustering built in. Not if you want to have, if you want to scale it, it becomes difficult. And because it's not built on Lucene, it lacks some of the more advanced features. This is with a disclaimer that I haven't worked with a Sphinx for the last 2 years anymore, so I'm guessing they catched up on some more of the advanced facets. I remember that last time I used it, they couldn't compute facet on string values. I'm not sure if this is the case today, but at that time it was definitely missing some of the more advanced features. And because of those downsides, actually like sites like Netlog and 2 are looking into, okay, what are the options, the other options we have? They really had to hack around some of the problems. Now if you're saying, okay, I'd like to use it, well, and you have probably an existing project, how can I do it? You can just add an extra layer to your application where you're sending both your data to your MySQL or whatever service you have, and also index it in Elasticsearch, which is pretty cool. You can just add a feature, you have all the stuff available for you. You might run into some consistency problems where a document is not exactly the same in your database as on the Elasticsearch cluster, but then I guess just the search isn't that important or not real time enough. But on the other hand, you could also just replace your database with it. An Engager, so those 1 billion messages are saved only in Elasticsearch. it is persistent. Everything you put in there is available. If it goes down and comes back up, then your data is still there. So you can just replace one table or a set of tables with your Elasticsearch cluster. And that's, of course, if you don't need the features that MySQL offers, like foreign keys. But then again, if you're using foreign keys, you're probably going to have performance problems anyways. Again, I think this shows that Elasticsearch is a very good engine, technically, but that still doesn't solve this problem. A research from this month where Nielsen, pretty highly regarded usability expert, just says that users suck at search. They're pathetic and useless. And I think at Engager we can sort of relate to that. We sometimes have clients coming to us, okay, I want to search for apples and pears. Okay, you search for apples and pears. That's not really what they want, right? What they want is apples or pears. So the problem, you can have a very good engine, but still that doesn't solve the problem of the users using that. The interface with the different statements I showed from Engager is a very, like, we're used to it, but it's very hard to communicate those ideas to our clients. So that's something to think about, I guess. If you say, okay, I want to play with it, and your boss is saying, no, it's too young, it's only 2 years old, it's not stable, okay, then just tell them this. SoundCloud is using it, StumbleUpon is using it, and maybe the coolest thing, Foursquare is using it. If you're checking in, what you see is locations near to you that you've checked in before, that your friends checked in, that are popular. That is powered by Elasticsearch. Where they come from is MongoDB, as an NoSQL, where I guess they're still storing that data, just assuming. Moved on to Solr, moved on to Elasticsearch. So if your boss thinks it's not really stable enough, maybe you should think again. And if you want like a service level agreement, there is, since a few months, there's not only the Elasticsearch project, like the open source project, but there's also the company behind it, like PHP has Zend, like MySQL has Oracle. There is a company where you can just go to, have training, have consultancy, have service level agreements. So I think that shows that Elasticsearch is, although it's only 2 years old, is a very mature product and something you can rely on. The sites you want to use, if you want to play around with it, or where you want to go, is elasticsearch.org. I remember that 2 years ago when we started, it was not very easy to find what you were looking for, and that's mostly because you're not really sure what you're looking for. I think this talk hopefully solves some of those problems, if you know what you're looking for. And it's also been redesigned in the process of making this presentation. It was all green, like my slides are, and then it just turned all white, so great. But if you want to have a question you don't find the answer on, you can use their IRC channel. There's mostly about 150 people on there, so you get an answer really quickly, and I think that's the best way to play around with it. And then I stole a slide from our CEO. Now I'm using one for myself. If you want to play around with any of these technologies, we really need new people right now. We're using Elasticsearch, but we're using also some other cool kits from on the block. What we're searching for right now is someone that's fluent in JavaScript, that knows Node.js, that knows how to play with Backbone. But other profiles, PHP developers, senior, junior, back-end, front-end, are always welcome to put in or to send over their CV. So then you know what we work with. If you want to know how it's like to work at Engager, go to startupshingle.tumblr.com. That's actually a Tumblr of some of my colleagues that shows how it is to work at a startup. Okay, let's stop with this and go right to questions. Yep.
I have a question about the join alike feature there is. I'm looking for a way, so I'm using Logstash to keep track of email logs, and I'm storing them in ElasticSearch. I'm looking for a way to find all messages with one message ID, but not just filtering out those, but having groups of them. Like having messages, all my logs grouped by that message ID. It's like a mixture of facets and joining.
Isn't the best way then to just combine multiple queries? Or you don't know the distribution in advance?
No, like emails could come in, emails could go out of that server, and it's like, it's not really sure, I'm not really sure if there's one coming in or multiple attempts to go out, so there's a mixture of all sorts of data, but there's one thing they have in common, they have a message ID. I want to group by message ID, so we can have a sort of trace of all the emails and what the history was in each email.
Yeah.
Aggregation.
Sorry?
I think aggregation like a movie.
I think the best way would be maybe to indeed compute a facet first and then use that data to do a second call for it. And do a combined call for it.
Fair enough.
Yeah. Anyone else?
What kind of servers do you buy for the ElasticSearch one? CPU one?
It's mostly memory. And for us it's mostly memory. The overhead of ElasticSearch itself is pretty small, but we need a lot of memory because of the indices that are, of course, faster if they're in memory. So
they have to be in memory to properly.
Yeah. Anyone else?
A small comment maybe in your comparison to Solar, and by the way I use both Solar and ElasticSearch. You compared actually to Solar 3 and not to Solar 4. So
okay, yeah.
Right now, feature-wise for let's say clustering and high availability and performance, they are getting closer.
Yeah, that's like we switched about a year ago, and at that point server management for us became a lot easier.
Yeah.
They both grow. They're both active projects. I'm demoing ElasticSearch because I'm using that one most, but I'm just saying that this was built with that from the start. That the Solar project has a longer history, but it can catch up, of course. Yeah. Maybe it's different tomorrow. It's even different today. So that's true.
Do you know the future plans for the project? If they have any new stuff coming up?
For Engager itself?
No, for the ElasticSearch.
Okay, what we're working on right now is like with nested documents. That's something. Okay, we have our database of messages, but we also have a database of actions on those messages, and that's especially for support teams. So, for instance, Movistar has a team of 6 people working with Engager on a daily basis. They assign it to each other, they add tags, they correct the sentiment. So a lot of actions they do on there. And what the team manager of that team, of course, wants to see is the performance of those things. So to compute like the average response time or how fast those users are, or how good those users are working, we need nested documents where we have the mentions and as a nested documents the actions on there. So that's something we're focusing right now for ElasticSearch. And adding servers. Okay, so thanks. I hope I hope I've shown that it's very easy to set up and very easy to use. So I think this might be a better option than trying to use MySQL. Thanks.
Thanks a lot, Jurriaan. I guess minds were blown here in the audience. I can see it. People were very silent, paying much attention to it. So we have a quick break right now, 15 minutes, and then it's up to Safi. Thank you.